Given that the quadratic equation k minus 1 x squared plus 2kx plus 7k minus 4 equals 0 has no real roots, show that 6k squared minus 11k plus 4 is greater than 0, and find the range of values of k satisfying this inequality. So, starting this question, initially, the important thing to take from this is that it says it has no real roots. So when discussing the roots in C1, what we're thinking about is the discriminant. So we have b squared minus 4ac, and we're looking at some sort of relationship with 0. For no real roots, we want b squared minus 4ac to be less than 0, so that the part underneath the square root is negative, and so that we can't get a real answer to the quadratic equation. Separately, I just want to state what a is. So that's k minus 1, the coefficient of x squared, b equals 2k, and c equals 7k minus 4. This is just to make sure that before I substitute it into the discriminant, I'm clear on what I'm using. So b squared is 2k squared. Please remember to put it inside brackets so you don't make any mistakes when dealing with the b squared term. Minus 4 times a, which is k minus 1, times c, which is 7k minus 4. And this is all less than 0. So I'm going to expand my brackets. So remembering that 2k squared means 2 squared times k squared. So this is 4k squared. Minus 4. And I'm just going to expand the bracket first of all. So I'm going to get 7k squared minus 4k minus 7k plus 4, all less than 0. So if I then expand the bracket again, so it's reasonable to do this in 2 steps to make sure I don't make any silly mistakes. 4 or minus 4 times 7k is minus 28k squared. Minus 4 times minus 4k is plus 16k. In fact, 1 second, before I do that, what I should be thinking about is minus 11k here. So minus 4 times minus 11 is plus 44k. That will speed things up for us. And then minus 4 times plus 4 gives us minus 16 less than 0. Tidying up, I get minus 24k squared plus 44k minus 16 less than 0. Now at this point, I'm quite close to this, although it might not look like it. To get from minus 24k to plus 6k, what I need to do is I just need to divide by minus 4. So just remember, if you divide by a negative number, I'm going to get the 6k squared. I'm going to get plus the 11k. So minus 11k that should be, because it's already plus, so we should flip the sign of that. Plus 4. And then the inequality sign flips because I've divided by a negative number, so I get greater than 0 as required. Finally, we now want to find a range of values of k satisfying this inequality. Remember that if you can't get to this result, this inequality here, just to start at this inequality and solve the inequality instead. So 6 times 4 is 24. I want factors of 24 that will give us minus 11 that have the same sign. So we're going to have 6k squared minus 3k minus 8k. So minus 3 and minus 8 add to minus 11, and minus 3 times minus 8 equals 24, plus 24. So plus 4 greater than 0. So factorising my first 2 terms, I can take 3k out as a common factor, leaving inside the bracket 2k minus 1. Second bracket, I can take out minus 4 as a common factor, so that I still get then 2k minus 1, all greater than 0. And finally finish off the factorising process by just taking 2k minus 1 outside as a common factor, leaving inside the second bracket 3k minus 4. And this is all greater than 0. Now what I want to do at this point is I want to state my roots, because I can't actually state my inequality just yet. My roots would come from 2k minus 1 equals 0, which would lead to add 1 divided by 2, k equals a half. And I'd also get 3k minus 4 equal to 0. So add 4 divided by 3, and I get k equals 4 thirds. If I sketch my quadratic, what I know then is it's got two roots. So something like this. The y-axis is going to be on the left-hand side, somewhere like that. So my first root here is a half. My second root here is 4 thirds. If you're not sure with the fractions, comparing the fractions, 4 thirds is greater than 1, so it's definitely greater than half. And so now what I'm looking for, if I use a highlighter pen to show you what I'm looking for, the area that I'm looking for is the part of the graph that's greater than 0. So I'm looking for this part of the graph here. That's the part that's relevant to me. Remember, it's the graph and not the plane, and this part of the graph. So in terms of my x values, I'm looking then to the left of a half and to the right of 4 thirds. So you can see here I have two distinct regions. I can describe this area here to the left of a half as x less than a half. And I can describe this area here to the right of 4 thirds as x greater than 4 thirds. And what we have to remember in this solution is that these are two completely distinct regions. They are separate, unbounded regions, and they can't both be true at the same time. So only one or the other can be true at any one time. Okay, well, let's have a look at how the marks are awarded in this question. First of all, if you've done the expression for b squared minus 4ac and you've got at least two of A, B, or C correct, you get a method mark. If you have got all three correct, you get an accuracy mark or an answer mark. If you have put this less than or equal to 0, so stated this kind of b squared minus 4ac is less than 0, we get a method mark. Continuing on, if you have shown convincingly how to expand and rearrange to get to the required inequality that was given in the question, you get an accuracy mark. Following on from this, if you have got these critical values, the roots, you get actually it's not an accuracy mark, so let's just rub that out. It's actually a standalone B1 mark. And then if you have got both of these inequalities correct, you can get 2 standalone B marks. If you don't use the strict inequalities, you lose a mark, and if you use the word and instead of or, you also lose a mark, so deduct 1 mark for each of those. Okay, I hope the solution made sense, and I hope marking it all and the explanation also made sense.